We're going to be doing a lab that talks about physical and chemical changes. So here are some things that you need to make sure that you write down in your notes. First things, observations are a key component of this lab and every lab we do. So good observations and something to remember is to use your senses, but not taste. Some other really great helpful hints is to maybe note the color, the state of matter. Is it a solid, liquid, or gas? The consistency or texture. A lot of students like to say things are clear or transparent, meaning you could see through them, or translucent. Translucent means light can pass through. If you were to shine like a flashlight through the liquid, could you see the light come through to the other side? Temperature is another really good one. Remember, sometimes you just need to take a qualitative temperature by just taking your back of your hand and touching the test tube. And odor, always remember to waft and not actually put your nose inside a beaker or a test tube. So these are some suggestions. Don't limit yourself just to these, but it's always good to keep this in a place that you can reference for future labs as well. In this lab, you're going to be asked to write down proof of whether or not you think the experiment you did was physical change or a chemical change. Some of your experiments that you do won't have anything to do with physical, and all of your proof will be in the chemical column. That is totally fine, and vice versa. So, and then some of your stations will have maybe one or two things written in the physical, let's say, but more things written in the chemical. Or you only have one thing written in the chemical and the rest are in the physical. So it's okay to have a column empty, but it's also okay to say I've got a couple here, but more in this column. The goal is to look and see which column did you put the most proof under, and then that will help lead to whether or not your change was chemical or physical, and obviously having a discussion. So using those notes would be good for you. Let's head on back to the lab and take a look at what's set up for you. So each station is back here, if you could see, with the components you need for that station, and there are going to be 5 stations, but it's going to get really crowded if we all come to this back table. And so I'm going to ask that you take what you need back to your stations, but then bring them back so other people can use them, and work out of order. Like, for example, if everybody's already started station 1 and you get here and notice there's things missing, then move on to another station. You can do them out of order, just come back and revisit them. All the stations are pretty quick, I'd say, except station 1 takes just a little bit of extra time. So keep your eye on the clock, and if you only have 5 or 6 minutes left, then maybe try station 2, 3, 4, or 5 instead. Give yourself a couple minutes to clean up as well. Always keep your eye on that clock. Some things I'd like to say about station 1 is you're using a compound called copper 2 chloride, seen here. Copper 2 chloride reacts with metal, and so if you look at our scupulas that I put here, you can see how the metal has started to corrode and react. So it's really important that you don't leave the scupula sitting in the chemical. Rather, recap all the bottles, okay? Because it reacts so violently with the metal scupula, I have set aside a few designated scupulas that are labeled that you should use. Again, look what it does to your metal. So don't use your own scupula. And if you remember, your own scupula is in your common drawer, seen here. You're going to need your own scupula for the other parts. So keep your clean scupula for the other parts and the other stations. Okay, so back to station 1. You're also going to need some aluminum foil. Please make sure you read the procedure, but the disposal is extremely important. There are specific disposal beakers for some of the stations. Again, read your lab so you know, but don't cross-contaminate the disposal, okay? Lastly, for station 1, you're going to need a thermometer. We don't have enough thermometers for you to keep in your personal drawer, so don't put it in your personal drawer. Instead, return it back here. But before you do so, please rinse it off and clean it with a scrub brush and some soap. Okay. Moving on, station 2 is pretty self-explanatory. Station 2 is going to require you to take the chemicals you need. Remember to always read the containers and take exactly what you're asked for. Don't just assume and start picking up everything. Okay, so obviously you're not going to need all of them. Take what you need, and the rest are for other groups to use. And when you do use your own test tube, remember you have your own personal drawer to make sure your stuff is clean. Okay, also remember that your other stuff that you need could be located down here in this cabinet, such as your test tube rack. Remember, a test tube goes in a test tube rack. It should not just be casually hanging out on your station because it can roll off and break. Okay, back to our chemicals here. Let's talk about station 3. If you notice, station 3 does have a specific beaker. Again, if you read your procedure, you will see that. Don't just assume. Please read. Also, make sure that you read the bottles. Like if I look here, this bottle looks like this bottle, but they're different things, okay? Remember to recap every bottle and to follow the directions. Moving on to station 4, over here. Station 4, the directions ask for you to cut an Alka-Seltzer in half. You only need to use the half and put it in your canister. This is a canister, make sure you have a lid. And here's some other canisters as well. Again, read about cleanup. And then on to station 5. Some things I want to mention about station 5 is if we look here at our acids, they are 3.0 M, capital M. Does not stand for meter, it stands for molarity, or we also use molar as an abbreviation. That gives me some information about this acid's concentration. Hydrochloric acid is a strong acid, and 3 molar in the world of molarity is kind of high. We buy hydrochloric acid in a 12 molar concentration, and then I dilute it for you in a 3 molar by adding water to it. So this is acid and water mixed together to make a 3 molar. You are definitely going to feel this if it drops on your hands. Remember, if you do spill any on your hands, good safety would be to wash your hands with soap and water because soap is a base and it will neutralize it until the stinging stops. Okay, and you're also going to be using some of these magnesiums. Remember, metals react with oxygen in the air, so to take what you need and recap all your bottles immediately, especially your liquids, because liquids like to evaporate too, so make sure that you recap everything. Now, you're going to be adding your acid to your metal in a test tube. So, talking about disposal, after you're done adding your magnesium and your hydrochloric acid together, you're going to then need to dispose your products that get made in your test tube. And in order to do this, you're going to be using your disposal beaker. So walk over here and dispose it. But as you see right now, I'm trying to dispose of my product and it just kind of stays at the bottom. And so I can lightly clink, but nothing dislodges. So if you could think of a few things that would help you dislodge this. A scupula, that would be really good. A stirring rod would be great as well. And also something that might be the best thing is to grab one of the deionized water bottles and put a little bit of water in here, as you'll see me do in a second, and then stir it around and dislodge that into here. So I'm going to demonstrate that for you right now. And it's okay if a little bit of the particles get left on the test tube at that point, but you don't want to use your scrub brush just yet because the scrub brush is just going to get all dirty. So as you can see here, I'm going to take the water and I'm going, okay, that's not good because I just dropped the video. Let's try that again. I hope you can hear me. You can only see Miss B's setup. All right, here we go again. Gonna put some water in here, then dislodge it, and let's see how I did. Ooh, still not good. So maybe I'm gonna hold it upside down and shoot water in at the same time and do a little clank. Getting better. There we go, yay. Now I'm gonna show you. So there's just a few little particles left. I'll try to put that down. Again, careful with the clanking. Again, maybe a scupula would be really good at this point. Okay, but at this point, hey, that's so little. It's okay if that little bit goes down the drain. And so I kind of want to show you, again, remind you that washing is not done with just water. You really need to get your scrub brush out. Remember that for all things in the lab. So you want your scrub brush and you want soap, right? So I'm going to put a little soap in here. You don't need a ton. Run the water. Good. Right, and then now scrub with your scrub brush. Let's see if I can put this down and do this for you. This is bad. Scrub brush brush and actually scrub your test tube as you see here. And let me see if I could balance my phone into this. No. So as you can see, I have some water and some soap in here and my scrub brush, and I'm just going to scrub my test tube, right? Clean it, rinse it out. And it's totally okay. Okay, hold on, I don't know if you can hear me. Totally okay to take your wet test tube, just kind of shake off the water and put it back in your drawer. It's not gonna hurt anybody, but just make sure it's clean when you do that. Scrub brush and actually scrub your test tube as you see here. And let me see if I could balance my phone into this. No.